Hey, welcome back. It's me, Mr. Truin. Today we're going over a new lesson in geometry, and today we're going to be looking at something called a tangent line. And I'm going to explain what a tangent line is, going to go through some different examples. Examples are a little daunting looking, but they're actually not too bad. In fact, once we explain it, you'll realize that most of everything in these is something that we've already done. It's just a matter of bringing it all together. So first things first is let me explain what a tangent line is. So a line that is called, quote, tangent is a line that intersects a circle at exactly one place along the edge of that circle. So a tangent line is going to have exactly one intersection with the circle. And a line that runs tangent also happens to form a certain angle with the center of that circle. And I'm going to go through all that here in a moment. So an easy example that you might see in everyday life of a tangent line is if you think about your car or your bicycle or anything with a wheel. When you ride your bicycle, for example, the wheel only truly intersects the road at one exact point, as it's a constant moving, but it's only intersecting, the wheel itself only intersects the actual sidewalk or the road at one particular point. And that's called a point of tangency. So in this picture right here, I got a bicycle, you have a point of tangency right here where that wheel meets the sidewalk in the same road for here. So when we look at a tangent line, they always intersect exactly one time. And another thing about a tangent line is the angle that is formed between the center of a circle and a tangent line is always going to be a right angle. We're always going to make a 90-degree angle with the tangent line and the radius. So when you take the radius and the tangent, they make a 90-degree angle. So when I look at, I got to keep those two things in mind, and then when I look at these examples, I have to think about that as I work each one of them out, because those have a lot to do with what we're doing here. All right, so when I look at the first example, it says AB is tangent to circle C. So right away, I automatically know that it is making a right angle, and that's really important because I need to know that before I proceed on with solving this problem. So right now I know that I have a right angle, which means that technically ABC is now a right triangle because I have a right angle. And that's important because we use a very famous formula over and over and over when we want anything to do with a right triangle. So in the problem it says, what is the length of AB? All right, so this is what I'm trying to figure out right here. And here's what I do know. The distance from C to A is 5. The distance from B to D is 8. All right, well, there's another thing that I also know here. A radius is a length that goes from the center of a circle to the edge of the circle. So if the distance from C to A is 5, what should the distance from C to B or D also be? Because it goes from the center to the edge. And that makes that 5. Well, now that I have that information, I can go back and I can figure out AB, because if I have a right triangle, this is the leg, and the distance from C to B is the hypotenuse. So I can go like this. I can say x squared, I'll call it x squared for this, we'll make this x, plus 5 squared equals 13 squared. Because if I take this one and this one and put them together, I get 13 squared. Well, working that out, I get x squared plus 25 equals 169. Take away 25, I've got x squared equals 144. That means that the distance from A to B is 12. By taking the square root, I get 12. And again, that's really important to recognize the fact that I made a right triangle. That's what I needed to know to solve the problem. Just like as I get to number 2, if I keep in mind that this is a tangent line, it says it's tangent, then this is 90 degrees. If I say that angle A is 25 degrees, and then I said, what's angle ABC? Well, again, I have a triangle, and we know that triangles have to make 180. So if I have 90 plus 25 plus angle ABC, I know it has to add up to 180. So that means that by subtracting, I got angle ABC. If I take away 90 and I take away 25, I should get 55 degrees. And that's this, because again, it has to make 180 degrees because it makes a triangle, and it makes very specifically a right triangle, so I already knew that number. So I can go ahead and fill it in as 55 degrees. All right, another thing that we're going to look at with tangents is when two lines are tangent, if you have, for example, a circle, and then there are two lines that are tangent to that same circle, those two lines become equal in length. They become congruent in length. So in this question, I'm asking, or I meant to ask, what is the perimeter of, I wanted the perimeter of ABC, which means I need to know the length all the way around from A to B to C. Well, if I need to figure that out, one of the things that's really important is knowing that AB, AC, and BC are tangents. Because once I know that, if this line is tangent and this line is tangent and they intersect at point B, then if this is 7, this is also 7. Just like this is also 4 and this is 3. So when I need to know what the perimeter is, I just need to total them all up. So I've got 2 7s, 2 4s, and 2 3s. So that's 14 plus 8 plus 6, add them all together and I get 28. The perimeter is 28. So again, the rule was, because these two lines, this line and this line, are tangent to the same circle, those two segments have to be the same in length. Therefore, this one and this one have to be the same distance away from B. All right, and the same thing goes with this one and this one. So this segment, these two are congruent, these two are congruent, and these two are congruent because they're both tangent to the same circle. All right, our last example is solving for the segment AC. This is a big one. This has got a lot going on, and this drawing came out of the book, and it's got a lot going on, and I get that. I'm trying to figure out the distance from A to C. So the most important thing I need to realize before I even get started is that the distance from A to C should also be the exact same distance from F to C. These have to be the same number. Well, looking at that, I can see that I am missing, I have a 29 here, which means I could put 29 here. But what I know that I'm missing out of this whole situation is I need to know the distance from B to C. And I don't have that. But you notice as I just drew that in, I did happen to notice that the segment from B to C is part of this triangle, which is a 90-degree triangle, which means it's a right triangle, and I need to figure out this distance. Well, I can do that if I think a little bit about how this whole thing works. If this distance from G to E is 9, and it's a radius, that means the distance from B to G is probably, or actually not probably, it is also 9. Just like the distance from here to here is also 9. Well, if you take all that information and remove it for a moment, maybe draw a small drawing off to the side, let's fill in everything we know. B to G is 9. This is X. 9 plus 32 gives me this distance right here is 41. I need to figure that out. So going through that, I'm going to write 9 squared plus X squared is 41 squared. Okay, well, 81 plus X squared, and then 41 squared, I don't remember what that is, 1681. Well, if I take 81 off of both sides, X squared is equal to 1600. Again, using square root, X would be 40. So this distance is 40. So when it says what's the distance from A to C, from A all the way to C, well, both sides are going to be the same. So this is 29, this is 29, this is 40. And A to C would be the sum of the two. So A to C would be equal to 69. All right, well, that's how tangents works, and that's our first part of the problems regarding tangents. So I hope this helps, and that's it.